Hey guys, it's Tom Trams with the FujiNet project, and I wanted to make a quick video showing an example application, a program that shows the position of the International Space Station, its point in space, relative to the Earth, latitude and longitude. We're grabbing the data from an API service, which is in JSON, and using the built-in JSON parser to process the data. So, I'll start by basically showing my typical environment here. And then as we show it working here, we'll start walking through the code to show you how it works. Go ahead, turn on the links. Come on. And I'll load the ISS program here. Now, because I'm still working out the timing of the protocols and stuff, each protocol operation has roughly a 1 second wait between it. And these will be removed in the final versions of the program. But you'll see right here, it opens up an HTTP connection, queries the data, and uses that to present a map on the screen. Pretty cool, huh? How does it work? Well, let's take a look. We'll start by going and picking up my little terminal window here. I just checked this in, so you can take and pull this from FujiNet apps in the ISS tracker folder. We'll start by going into the links folder. And I borrowed the project structure from Atari Lynx Gamer. Thanks a lot. It's a very fantastic makefile structure for Lynx applications. It takes care of all of the details of not only compiling the code and keeping it nice and separate, but it also deals with sprite packing, which I needed for this particular demonstration here. In fact, if you look at the display coming from the links, you'll find that two sprites are being used, the one for the background and the ISS in front. If we take a look inside of the main program itself, we'll see not much is going on. Some includes, some defines to indicate the JSON channel that we want to talk to, and the network device, which is device number 9 on the FujiNet here, and some URLs. In FujiNet, we have the concept of a network device and protocol adapters, which you can use to solve a particular problem. We have roughly about a dozen different protocol adapters, and HTTP is one of them. After which it looks like the standard URL. Grabbing a piece of JSON, and we have a couple more variables here to show for queries to take and find the ISS position for its longitude and its latitude. In fact, these actually correspond exactly to the positions of the parsed JSON that you see here. And we're not using the timestamp yet, so it's not parsed, but it is there and available for us to use. And you can actually see right here that we're doing the queries to find the above pieces of information. We have a couple of data structures here to make things a bit easier. This one is for opening a channel. The command, which is O, capital O for this case, for open. The mode, in which case we want to use get, which is 12. And any translation, such as changing end of lines from character turns and line feeds into another format, is possible here. We're not using that in this case, but it has to be specified. And finally, the URL that we are open. We also have one for setting the channel mode. And this is needed so that we can take and tell the HTTP protocol adapter that the links isn't going to be processing the HTML, but the JSON parser in the FujiNet itself needs to process it. So we use this command here to do that. And we set the mode below. We have some variables here to take and hold the string values for longitude and latitude, which we'll take and convert in just a minute. And we have one for timestamp, even though we're not really using it yet. Some basic things, if you've already are familiar with Link's development on C to initialize the graphics hardware, but we have a new one here called FujiNet init. What is that? Well, if we take a look, and in fact, I'll do the rest of this in Emacs. If we take a look, we'll see FujiNet init deals with setting up the serial port for comlinks use. We set it up, turn on the interrupts, and return. After which point, okay, let me get back to what we were. We can do some more housekeeping for the graphics, but here is the first little bit of FujiNet code. We set up our packet, which contains open, the mode that it needs to open into, whether or not we need translation or not, we don't. We copy the URL into the data structure, and then we send it off. FujiNet send will send whatever unsigned whatever sequence of characters that you want off down the com links. There is a little bit of what stuff that gets wrapped around in it. Basically, we wrap whatever gets sent into a send packet, which has an identifier saying that it's a send packet, the length of how long that send packet is, and an XOR checksum at the end of that packet. But this helps package everything up nice and neat to send off to the FujiNet. And in fact, if we take a look, we can actually see immediately the type of packet structure that we're setting up here. Setting up the headers for the packet, copying in the body payload, calculating the checksum at the end, and finally sending out the data as quickly as we possibly can. Now, because comlinks is a one-wire serial bus, it's important for us to get rid of any data that we have sent from our input buffer, because we're inevitably going to see an echo of what we sent out. So it's important for us to take and clear that out. You'll see that a lot in this particular kind of code. Then we finally get the response. And that gets returned. And there are a couple of responses, essentially. ACK, meaning that the FujiNet accepted the send packet that you gave it, or NACK, meaning that it didn't. We have a little function here primarily to handle with what we call the clear to send packet, which is used down here in FujiNet receive. And we'll see how that goes in just a moment. But for right now, what you see is us calling an open command, sleeping for a second, calling a command to set the channel mode to JSON, sending that down the pipe, and finally telling the FujiNet that we want to parse the JSON that we have opened in our HTTP protocol adapter, at which point the FujiNet will take that data and process it and leave it in the ESP32 memory so that you can query it at your leisure. At which point, we can immediately start doing queries. Recall that the queries are up here, and they look like these guys right here. Bam, bam, right there. And once we do a query, we immediately can turn around and ask it to send the response back for that query. Now, the receive command is a bit more involved because we have to do a little bit of handshaking. We have to basically say, okay, yes, we want to receive, we wait for data, and if there is nothing to receive, we simply just return and say, okay, fine, there's a NACK, nothing happened. But if there is, we immediately fire off a clear to send, meaning that the links is ready to receive the information. We get the first and the second length bytes, which give us a total max of 65,535 characters that we can put into a packet. We grab the payload, we get the checksum. And while I was testing, I took out the checksum check down here, but I could just as easily take and do it down here and respond with either an ACK or an ACK. So with that, those are the primitives that you need to talk to the FujiNet. That's it. Send and receive. You don't really need anything else. Everything else is in the type of packet that you fashion to the FujiNet to send. So with that, we can go back to main here, and you can see that all we're doing is grabbing the query of the data that we want to use, and then immediately passing that off to the ISS function, which takes those latitude and longitude values and converts them into pixel positions for the sprite. That's it. Set up our sprite control blocks for the images, but we don't actually draw the sprite here. We just set it up. We set up the scub here for these two values, and we turn right back around. And if we go to map, which is the next function that gets called, we see that our ISS sprite is the next sprite in the list for our scub. That's it. Finally, we just output it. Bam. All at once. So that's really it. That's all that needs to happen in order to take and grab a piece, to take and call a networked endpoint and retrieve some information from it. We'll do it again. Come on. Let's try to make this thing focus. I guess not. And we'll see it again. You'll see that the open happens. We get the data, we get the query, and we get the result. And again, well, looks like that one didn't parse, but we'll try it again. No big deal. Still working out the protocol timing. I'll just reset the device. So set protocol, set channel mode, get the JSON, parse it out, and there's the result. So there you go. That's it. I'll be making more videos along as this goes along, but wanted you guys to see this firsthand on how this worked. So until next time, guys, have fun.